You know those headlines, right? New study finds a significant link between, well, whatever. But what does that word significant actually mean when a scientist says it? Turns out, it might not mean what you think. Today, we're going to pull back the curtain and find out what research results are really telling us. Let's get into it.
All right, let's start with a bit of a head-scratcher. This quote says a drug can be statistically significant, but at the same time have no clinical relevance. How is that even possible? How can something be significant but not important? It sounds like a total contradiction, but this right here is the key to a massive misunderstanding in how we interpret science. And that leads us straight into our first big topic, the significance trap. We're going to look at the one tool that's at the heart of all this confusion, the p-value.
So what on earth is a p-value? Okay, imagine you're testing a new plant fertilizer. Your starting point, what scientists call the null hypothesis, is to assume the fertilizer does absolutely nothing. The p-value then answers this question. If this fertilizer is totally useless, what are the odds I'd see these amazing results just by pure random chance? So a super low p-value means it's really unlikely you just got lucky. It's kind of like a fluke detector.
Now, you've probably seen this before. P is less than 0.05. For decades, this has been the magic number. It's this arbitrary line in the sand that says if your result is below this, congratulations, you can call it statistically significant. But this is exactly where the trouble begins.
See, the p-value can be a real trap. First off, it tells you zero, zilch, about the size of the effect, or how important it is. And second, and this is the kicker, it's hugely influenced by the sample size. If you run a study with enough people, you can get a significant result for an effect that is so tiny it's completely meaningless in the real world, like that 1 millimeter drop in blood pressure we saw earlier.
So if the p-value is not telling us how important an effect is, what does? We need a better tool. Let's figure out how we can actually measure the magnitude of a finding.
This is the million-dollar question, right? We know something is probably happening, but is it a tiny nudge or a massive shove? Is this a change that's actually going to make a real difference in anyone's life?
And the answer is something called effect size. This, my friends, is our first hero of the day. Unlike the p-value, effect size strips away the influence of the sample size. It just tells you one thing: how big is the punch? It's the so what metric. It tells you if a finding actually matters in the real world.
And this visualizes it perfectly. On the left, with a small effect, you can see the results from two groups. Let's say one group got a new drug and the other got a placebo. They mostly overlap. It's hard to tell them apart. But on the right, with a large effect size, wow, those two groups are clearly separate. The treatment is obviously doing something powerful.
Now, if you're ever brave enough to dive into an actual research paper, you might see a term like Cohen's d. It sounds technical, I know, but don't worry about it. You don't need to know the math. Just recognize that when you see it, it's one of the most common ways that scientists put a number on just how big their finding is. It's a standard label for the effect size.
Okay, great. So now we know how big the effect is. But how sure are we about that number? This brings us to the second hero of our story, figuring out how to gauge the precision of our estimate.
I mean, think about it. Any single study is just a small snapshot of the entire population, right? So the effect size they calculate is just an estimate. The real question is, how good of an estimate is it? Is it a wild guess, or is it a really precise measurement?
And that's where the confidence interval, or CI, comes into play. A CI is brilliant. Instead of giving you one single number, it gives you a plausible range for where the true effect lies. It gives you an upper and lower boundary, which tells you exactly how much uncertainty we're dealing with.
Let's go back to that blood pressure drug. Say a study finds it lowers blood pressure by an average of 10 points. That single number, 10, is what we call the point estimate. It's the best guess from this one study, but it's almost definitely not the exact true value for every single person.
So, a good study won't just report the 10. They'll also give you a 95% confidence interval, maybe something like 5 to 15. What this means is that we can be 95% confident that the true effect of this drug for the entire population is somewhere in that range. It's a much more honest and complete way to look at it.
So how is this range built? It's actually pretty straightforward. You start with that point estimate, the main result from your sample. Then you calculate a margin of error, which is based on how big your sample was and how much the results varied. And the confidence interval is simply that main result plus or minus the margin of error.
And here is the absolute key. That margin of error? It shrinks as you add more people to your study. It's a simple, direct relationship. More data means less guesswork. So bigger studies give you these nice, tight, narrow confidence intervals, which means we can be much more, well, confident in the result. It's all about precision.
So, let's put it all together. We have our three key tools: the p-value, the effect size, and the confidence interval. When you use them together, they tell you the full story behind the research.
This table sums it up beautifully. The p-value is about likelihood. Is something real happening, or is this just random noise? Effect size is about magnitude. Okay, it's real, but is it big enough to actually matter? And the confidence interval is about precision. How sure are we about that size? You need all three pieces of the puzzle to see the whole picture.
So why do you need to know all this? Because understanding this trio of tools is like having a superpower. It lets you become a much smarter, more critical consumer of information.
So here's your new toolkit. From now on, when you see that word significant, let it be a red flag. I want you to ask, okay, but how big was the effect? Is this a game changer or just a tiny blip? Then ask, and what's the confidence interval? How certain are they? Answering these questions helps you make way better decisions about your health, about the news you trust, about everything.
So, I'll leave you with this. The next time you see a flashy headline screaming about significant results, you'll know better. You'll know that's just the beginning of the story, not the end. Because now you have the power to ask the right questions and find out what the research really means. Thanks for watching.